Good morning, everyone. How are you? Our lesson today is Pythagoras theorem. Okay?
What do Euclid, 12-year-old Einstein, and American President James Garfield have in common? They all came up with elegant proofs for the famous Pythagorean theorem, the rule that says for a right triangle, the square of one side plus the square of the other side is equal to the square of the hypotenuse. In other words, a squared plus b squared equals c squared. This statement is one of the most fundamental rules of geometry and the basis for practical applications like constructing stable buildings and triangulating GPS coordinates. The theorem is named for Pythagoras, a Greek philosopher and mathematician in the 6th century BC, but it was known more than 1,000 years earlier. A Babylonian tablet from around 1800 BC lists 15 sets of numbers that satisfy the theorem. Some historians speculate that ancient Egyptian surveyors used one such set of numbers, 3, 4, 5, to make square corners. The theory is that surveyors could stretch a knotted rope with 12 equal segments to form a triangle with sides of length 3, 4, and 5. According to the converse of the Pythagorean theorem, that has to make a right triangle, and therefore a square corner. And the earliest known Indian mathematical texts, written between 800 and 600 BC, state that a rope stretched across the diagonal of a square produces a square twice as large as the original one. That relationship can be derived from the Pythagorean theorem. But how do we know that the theorem is true for every right triangle on a flat surface, not just the ones these mathematicians and surveyors knew about? Because we can prove it. Proofs use existing mathematical rules and logic to demonstrate that a theorem must hold true all the time. One classic proof, often attributed to Pythagoras himself, uses a strategy called proof by rearrangement. Take 4 identical right triangles, with side lengths A and B, and hypotenuse length C. Arrange them so that their hypotenuses form a tilted square. The area of that square is c squared. Now rearrange the triangles into 2 rectangles, leaving smaller squares on either side. The areas of those squares are a squared and b squared. Here's the key. The total area of the figure didn't change, and the areas of the triangles didn't change. So the empty space in one, c squared, must be equal to the empty space in the other, a squared plus b squared.
Now, middle one, we have the text of Pythagoras theorem, which is the sum of areas of the squares on the 2 sides of the right angle triangle equals the area of the square which based on the hypotenuse. And we have 3 rules. We have to follow them to get the missing side in any right angle triangle. The first rule, the missing side is BC, which is the hypotenuse, equals BC bar 2 equals AB bar 2 plus AC bar 2. The second rule, to get the side AB, AB bar 2 equals BC bar 2 minus AC bar 2. We have to start with the hypotenuse because we have subtraction. The third rule, AC bar 2 equals BC bar 2 minus AB bar 2. Now, you can open your booklet, page 52, to solve more exercises on the theorem. The first example which we have it, he asked me to find the missing side which is AC. So I have to ask myself, AC is the hypotenuse. So which rule I can use it? The first rule. Excellent. But before we start to write the rule, we have to write the condition of the right angle triangle. Since measure of angle B equals 90, therefore AC power 2 equals AB power 2 plus BC power 2 equals 6 power 2 plus 8 power 2 equals 100. So to get the side AC, I have to get the square root of 100, which is 10 centimeters. And this is the length and must be positive length. Let's move to the second one. To get AB, AB is the side or the hypotenuse in this triangle? Side. Excellent. First step, I have to write the condition. Since measure of angle B equals 90, therefore AB power 2 equals AC power 2 minus BC power 2 equals 13 power 2 minus 5 power 2 equals 144. So to get AB, I have to get the square root of 144 equals 12 centimeters. Okay, let's move to the next page. Page 53, we have an exercise on Pythagoras theorem. The figure which he gave it to me is a triangle ABC, and we have AD is perpendicular to the base BC. He asked me to find the length of AD. This is the first required. So which triangle we have to start with it? We can start with the triangle ADB. Excellent. No, we cannot start with the triangle ABD because this triangle has only one side. So we have to start with the second triangle, which is ADC. Why, Mr.? Because we have two sides, and we have one side is missing. So we can get AD. AD is the side or hypotenuse is the side. Yes. So to get AB, which rule we can use it? The second rule. But first we have to write the condition of the right angle. Since measure of angle D equals 90, therefore AD power 2 equals AC power 2 minus CD power 2 equals 20 power 2 minus 16 power 2 equals 144. So to get AD, we have to get the square root of 144 equals 12 centimeters. You understand? Okay. Let's move to the second required. He asked me to get the area of the square on the side AB. What it does mean? To get the area of the square on the side AB, it means I have to get AB power 2. So where is the side AB lie? The side AB lies in the triangle ABD, and its name is the hypotenuse of the triangle. So which rule I can use it? Excellent, the first rule. So we can start. Since measure of angle D equals 90, therefore AB power 2 equals AD power 2 plus BD power 2 equals 12 power 2 plus 9 power 2 equals 225. Therefore AB power 2 equals 225 centimeters square. So the area of the square which on the side AB equals 225 centimeters square. Okay, middle one, you understand? Okay. Let's move to the next required. He asked me to get the area of the triangle ABC. We have studied before the area of the triangle equals half times base times height. So we have the base BC, its length 25. And where is the height? The height is AD. Its length equals 12. So the area equals 150 centimeters square. That's okay. Let's move to the last exercise which we have today. Go to page 54 in your booklet. We have this example. He asked me to find AC. So I have to ask myself, AC, which lie? Where is lie AC? AC belong to the side, to the triangle ABC, and also lies where in the triangle ACD. So which triangle we can start with it? I can start with the triangle ACD. Excellent. No, I have to start with the triangle ABC because this triangle has two sides and I have to get the missing side, which is AC. To get AC, we have to start with the condition of the Pythagoras. Measure of angle B equals 90. Yes. So AC power 2 equals AB power 2 plus BC power 2 equals 9 power 2 plus 12 power 2 equal to 125. Therefore, AC equals square root 225 equals 15 centimeters. You get it? Okay. Go to the next required. He asked me to get AD power 2. AD power 2 where in the triangle ACD, and its name is the hypotenuse of the triangle. So we can start by the same way. Since measure of angle C equals 90, therefore AD power 2 equals AC power 2 plus DC power 2 equals 15 power 2 plus 20 power 2 equals 625. That's right. We have another required. He asked me to get the parameter of the figure ABCD. ABCD. To get the parameter, we have studied before. The parameter is the sum of outer sides. So the parameter here will be the sum of the sides AB plus BC plus CD plus AD. I have to get the sum of them and it will be 66 centimeters. Okay, middle one, you understand it? Thank you very much. This is the end of our lesson today, and this lesson is very, very important. You have to study this lesson because this lesson is very important in middle 2 and in middle 3. Thank you and goodbye.